Winding layers of winding one over the another is called concentric winding. In transformer, low voltage winding is wound over the core and above this layer is wound high voltage winding. This arrangement of winding is known as concentric winding. Concentrated winding is employed where number of slots on the armature is equal to number of poles in the machine. This armature winding of alternator gives maximum output voltage but not exactly sinusoidal. The most simple single-phase winding is shown below in the figure below. Here, number poles equals number of slots equals number of coil sides. Here, one coil side is inside one slot under one pole and other coil side inside other slot under next pole. Clearly the EMF induced in one coil side is added to that of adjacent coil side. This arrangement of armature winding of alternator is known as skeleton wave winding. As per the figure below, coil side 1 under N pole is connected to coil side 2 under S pole at the back and coil side 3 at the front and so on. The direction of induced EMF of coil side 1 is upward and EMF induced in coil side 2 is downward. Again, as coil side 3 is under N pole, it will have EMF in upward direction and so on. Hence total EMF is summation of EMF of all coil sides. This form of armature winding is quite simple but rarely used as this requires considerable space for end connection of every coil side or conductor. This problem can be overcome, some extent, by using multi-turns coil. In order to get higher EMF, the multi-turn half-coiled winding is used. Since the coils cover only one half of the armature periphery, thus, this winding is referred as half-coiled or hemitropic winding. This is shown in the below figure. If the coils are distributed over the whole armature periphery, then the armature winding of alternator is referred as whole-coiled winding. As shown in the following figure, it is double layer winding, where one side of each coil placed on the top of armature slot where other side is placed in the bottom of the slot, represented by dotted lines. Hence it is essentially a double layer winding. But in a synchronous machine we mostly desire output to be sinusoidal, more efficient, balanced air gap distribution. With this regards we prefer distributed winding over concentric one. Now if you require trapezoidal wave output with more magnitude and less power rating, you should use concentric winding. Major difference is removal of harmonics in case of distributed winding, which will cause a sinusoidal output. Due to distributed winding, the resultant induced EMF in the winding will reduce. But due to more spreading of winding, efficient cooling can be employed in distributed winding, which will reduce the losses in the machine. So mostly machine will have distributed winding. Now coming back to lesson, we were talking about the wiring diagram and hence I have now been decided my wiring circuit for each winding. As the next step now I'm going to decide the diameters of conductors. In my case, I will use copper winding wires for each winding. Since we have to keep maintaining the magnitude of our MF in auxiliary winding always to be greater than the main winding, I thought to go for the following diameters. Depending on your favor and the budget, you can either change and substitute by whatever the diameters you would like to go for. For my main winding, I thought to use the Class H enameled winding copper wires with the diameter of 0.8 mm, and for the auxiliary winding, I'm going to use the winding copper wires with the diameter of 0.56 mm. I repeat you, that you can change not just diameters, all the characteristics of stator, wiring diagram, pitches, nerve slots etc. depending on your interest at your design. Now we are coming to one of important sections during our journey, and it is to determine and calculate the resistances of each coil depending on the volume we are going to use for each winding. To understand it easily, neglect the pitches and pattern. Think only about the know of poles of each winding. As you are aware, it is 2. Hence each pole is to be produced by a bunch of copper wires wound.